So people from Nokia may remember that a few years ago, a huge quantity of human resources at Nokia were spent to answer one single question. And the question was, who's leading in 5G? And it's very funny because today, thanks to LLM, we can very easily answer the question. Okay, and you see, it's very fast. So the grad that was Nokia's a few years ago is now very easy. Everyone can do that.
The trick is to have something that answers with Nokia in the answer.
Yeah, Nokia is the answer. It's there, in fact, which relatively great, but optimistic. Yes, you can answer as a pirate if you want. I like that one. And so you see, you can answer. Well, if you have a specific question, you can ask them. But, so for Marcus, it's fun because sometimes he reminds that he was very loud. Sometimes he forgets. It's the thing with LLM. You know, they got not a strict way of storing knowledge. So sometimes it's accurate, sometimes it's hallucinating. For kids, usually it's a nice one. I think it's relatively a good description of what Marcus wanted to be. So I like this one. If someone in the assistance wants to ask some question, don't hesitate. It's LLM.
What is it?
Oh, I'm afraid
you have an interesting hallucination.
Yeah. What is links? Toolkits. No? Big library for grown-ups want to run new things on the computer.
Good try.
Yeah, honestly. Calamba. Usually for kids, it's relatively generous. Learning Infonet cooperative system. Yeah. Maybe it exists. We don't know. Good question. Yes, sometimes it works, sometimes it doesn't. I still have difficulties to find prompting the thingy, so French, I need to adjust.
The question is in English, so it's
yeah. Labeling informatique de synthèse. It does the job. Okay. So if you want to do this interactively, I don't know if it's preparation. The main package that you need to get is Llama CPP. Well, IPyWidgets as well, but usually it's shipped with regular distributions like Conda and such. So Llama CPP is more rare. And the Python version. There's a GitHub here. And if you've got a CUDA, you've got to do some mumbo jumbo during installation so it understands that you can use CUDA. And if you want to run it on a remote server, you've got to ask for the server option during installation. Blah, blah, blah. And for Windows, so there is a gist where it is summarized, but Windows user will have extra steps to perform, like installing a compiler and such. But it's not impossible. And sometimes you get, well, it's in the gist, go to the next site if you want to do that. As well, if you want to do this on your side, you will have, well, it would have been better to do that beforehand, to download a model from a Hugging Face. So you have to download the GGUF model and we'll tell you what it is. And I recommend for practical to use the Phi2 model, Phi2 GGUF from the blog. And there will be a bunch of models. Choose one from the middle, it will be plenty. Okay, but I will have the LLM explanation for the end, of course, because I want to build the intensity in the GTT. And I will start with IPyWidgets. So IPyWidgets is something that Joanne Degremont introduced to me, and I didn't know about that. And it was actually kind of fun. It's a way to build interactive widgets inside the Jupyter Notebook. And the main benefit is it's basically instant to make. So if you want to basically discuss some parameter tuning with some colleagues, or if you want to have a cheap wow effect, IPyWidget is something that you can do. The only thing is it's designed to be interactive. So what it changed must be computable in real time. Otherwise, it doesn't make sense. And inside IPyWidget, there is one method that kind of does maybe 95% of the things you'd like to do, and it is interact. Just by example, imagine you've got a function that takes as parameter something, and you just interact this function, and you set default value for something, and ta-da! You have automatically this widget where you can change things if you want, and in real time, it's modified. Main issue is, okay, we have the function because this is actually the signature of interact. But it's a thing that already existed, but I forgot. If you add a semicolon at the end of a command, it strips out the output. So you have exactly what you wanted. Just a simple widget. Nice. And it doesn't stop there. So here it was, okay, I entered a string.
So yeah, well, why is there semicolon in one case and not in the other?
Yes, this is yeah, because it's the output of interact. Maybe I didn't try. Can you do that? Yeah. Good remark. But the thing about interact is it's very versatile. Like if something is an integer, you've got int slider. If it's a float, you've got a float slider. And here, what will you have? Well, you will have something between 0 and 5 integer because it's the signature. And here, can you guess? Exactly. Yep, question? So I don't remember if you can specify it with interact as well. Maybe. Yeah, here it takes the middle. I don't remember if it's easy to customize with just interact. I will see later that when you want to customize things, you don't use interact anymore. But interact is the instant way. So if you have choices, and here I could have a list, but I decided to use a list of tuples. What happens is you've got choice, and the description is the left part, and the output is the right part. And you can use a dictionary if you want. It's exactly the same. So, okay. And interact, if you want, you can use it as a decorator. That's another case when you want to be quick and dirty and just do it in one way. You interact inside the decorator. You specify all the values that you want to use with the same system, either default values or some range or something like that. And here you are. And you see, so this is a multi-decorator with different parameters, and anytime you do something, it's changed. Nice. And you see, it's so simple, it's absolutely. No, the at tells it's decorator.
Yes.
Maybe. Honestly, decorator, it's still a bit of black magic for me. François, maybe you know a bit more about that.
Yes, essentially, when you define the decorator, it just means that it's something that what will follow will be the first argument. Something there is depth, interact, and at interact.
Okay. So if you want to do plots, and many people want plots, for instance, so it's exactly the same thing. So you define a plot function with some parameters. So here I have one sinus, one cosinus, and a few parameters to set up scale, frequency, color, whatever, who cares. And so you send that to interact. So this is a arise issue. Yep. Okay, good enough. And you see that if I change, for instance, the frequency, immediately the frequency adjusts. If I change the relative values of the curve, it switch around. If I change the color of the curves, that immediately. Very easy, very simple. Here I use the fact that you can have Unicode characters for variables. Yeah.
Just for information, if people want to test, in fact, when you, so I just tried and restarting the kernel of the kernel is not enough. In fact, you have to restart Jupyter itself.
Right. And you've got to have a recent version of Notebook, at least 6.5.6, I believe. Otherwise, you have some JavaScript issues because JavaScripts always evolve. Solid function in JavaScript always grows. Yep. Is it done? I don't know. I don't know about the VS Code engine. IPyWidgets stands for IPython widgets. So actually, it's not actually Jupyter, but the IPython backend that's running. So if VS Code uses IPython as a backend, it should work. Let's continue. So interact, yeah, quick, dirty, not many customization possible, but plenty of stuff. Now, let's say you want to do something very specific. The recipe is actually simple. You do a Lego construction where you will have input pieces, output pieces, and joiners that tell you to stack this horizontally, vertically, whatever. And I always like to lead by example. So here I will remake the previous proof with plots, but manually. So you use specific widgets. Oh, by the way, I forgot. You've got the huge list of available widgets if you follow the link, and all the things you can think of, all the things that are part of the current standard for HTML slides and things is available there. And for instance, you've got sliders, int slider, float slider, where you define the minimum, the maximum, the step if you want, the default value, the description, which is the text that is entered. Continuous update for sliders. So it's specific, but that I sometimes use for LLM, for instance. By default, when you have your mouse on the handle and you slide, it continuously try to update the thing. If you set it to false, it waits for the mouse to be released before it updates. Similarly, for text box, if you have continuous update, for each single new character you add or delete, it will update the thingies. But if you click on continuous update, it will wait for you to go out of the text box to do the update. So when you have something that is almost real time, it can be good to disable continuous update. And I want to set that as the parameters. So I use a vertical box where I will stack the two sliders. Then I will have color choice input, which are of the drop-down type. So I create them. I add the description to tell what their impact, and I box them. And then I box the color control and the parameter control in generic controls. Yeah. So you've got this. Of course, it's not plugged to anything yet. So what do? We create the output like this. So you define the function that you want to use for output. It can output some print, some plot, whatever that has some display. And you use the interactive output widget that takes as a function, that takes as a first argument the function that will be used, and then a dictionary where you specify the parameter and which widget to use to get these parameters. Like for instance, this one has a parameter alpha is there, and it must use the widget alpha to get it. And just to see, so this is the same alpha. So it tells, okay, go from this widget and takes the value of this widget to the getDect. Very easy. And you glue things together with the hatchbox. And oh yes, I forgot some evaluation. Yes. 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 And here you have, so this one with continuous updates here and there. And here you see nothing happens. I release and it is evaluated. So continuous update is false there. Of course, there's many other parameters I didn't cover here, but you've got the main recipe. So yeah. So my conclusion about the IPyWidget part is it really in seconds, literally, you can make an interactive demo and very easy to interact. If you want to fine tune completely things, well, you at some point you have to do some JavaScript in the middle. So with you got some handlers, some callbacks, and yeah, it can be heavier and heavier. But yeah, it's very simple and relatively simple is to stack widgets together, and just with these two approaches, you already have a lot of things you can do. Yeah, exactly. Yeah. And actually, it's you learn the easy things in what I showed you plot. The next part is to learn the hard thing, that is knowing how it runs underneath. Yeah. Yes.
The harder question, example in plot, we have a single plot update that plot.
Yeah.
So the track where how does it not move?
So what I show you is actually recreating the plot, and there is something called IPyMLP, like matplotlib for IPython, that kind of do what you suggest, but instead of recurring every time, is smartly changing and updating the canvas. But I tried and failed and didn't want to spend much time on it. So if you want something more fluid, maybe you've got to learn how to make things work with the IPyMLP plugin. Hmm? Yes. Because actually it's destroyed and recreated every time. I'm not sure show is necessary, but I always want show. So. Yes. But for example, I will try to do something, sorry. For example, if I do yes, but here I call the function. And actually, IPyWidgets does that because I suppose it must cache the thingies, wait for the output to be made, and that. Yeah.
In IPython, you can ask the output to be erased. And for example, you can emulate a very simple progress bar by doing that. Very good example. I'm not that sure because the progress bar, like I said, you will not see it. You will not see it. I agree. Yeah, I'm working. Because here, not erasing the block. I don't know. Not
if you want to investigate, you're mostly welcome. Personally, I don't care. Okay, and now the putaclic part about large language models. So, blah, 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 LLMs are what is used to fuel all the modern and fantastic tools like ChatGPT. I love students uses ChatGPT in the exams. Yeah, it's so good to read Bard, Gemini, Claude, Mistral, whatever. So it's based on the Transformer framework. That was, I remember it was network theory session of a working group 7 years ago from Leo. Was building there, and yeah, back then, yes, yeah, another architecture for networks, but actually it's overwhelming today. So very nice one. And we just I will not tell you how to train a new model, just give you a recipe. So you need to take as many NVIDIA A100 as you can. So just to show you, this is NVIDIA A100. So you see, you don't have any output anymore. You don't care, but you have a nice price. And actually, it's very difficult to find them today because all the supplies is used to train LLMs. So it's almost, well, maybe it's expensive price, but it's almost impossible for regular user to, for personal user, individuals to get one of them. So you take many. You take all the internet. You book a power plant because I believe that in recent papers, you know, that save a number of tons of CO2, sorry, that was required to produce, and it's thousands to train a huge model like a Falcon model or a Mistral model. It's really thousands of tons of CO2 that are required, and it takes a few months. And ta-da, you have a large language model. Another thing that we'll not discuss today is about how to fine-tune LLM. So it's kind of the easy part because you have already something with kind of intelligence, and you just need to give some instruction to perform some specific task. And the recipe, so you start from a relatively good LLM, so you know power plant, things like that. You still need good GPUs, but regular NVIDIA are enough. I made some experiment, for instance, in Hyperion. It's feasible to fine-tune some models in a few days. So it works. And the key is you prepare a very small relatively to the internet data set that kind of explain what you expect from the LLM. And you do, so either you retrain the LLM starting from the initial model, or you do what they call LoRa training. So basically, you learn how to modify the weight of the initial model to have a new model. And many people do that because you can have one base model and have then multiple LoRa plugins that are just modifiers of the weights. And with that, you can have multiple types of fine-tuning based on one single model. So it can be advantageous. For instance, you can deploy the same things on the same architecture and just on the fly change the LoRa overhead. So you can do things like that. But I will not speak about that today, despite the fact that I spent already a couple of minutes. So today is about how do you use LLM in everyday life. Well, if you want a very good control of everything, if you really want to play with hyperparameters very deeply, you have a huge ecosystem that exists, mostly based on Hugging Face, and you can do whatever you want with the open source LLM. It's very nice. You can use, for instance, the plantation from the Java side as an entry point to see how to do that. But here, it's a little bit different. We will rely on a standalone approach based on the Llama CPP, which is something we discuss later, and it's Python template. So Hugging Face, I hope many of you know what it is. It's basically the GitHub of machine learning. And for LLM, it's got a nice leaderboard that you can use to kind of show and see what's happening today. So today, in the leaderboard, what do we have? Okay, a new one. SF Foundation is now on top of the keyboard. Basically, just tell you what are the best open source LLM at the moment, based on some metrics. I insist on that, based on some metrics. And many of the people that are in the leaderboard are actually building fine-tuned LLM that are dedicated to beat the numbers them. So it's not always the best choice to take the highest LLM, the highest score there, but still it's good to see what's going on these days. I'm curious. So what's this one? Okay, more information needed, more information needed, more information needed. Okay, so it's what we call work in progress. So I wouldn't twist that for now. Anyway, it's too big for me. I don't know. Google the Geekfest leaderboard LLM. Maybe it's the best solution. Well, point is, you've got many things there. Just a few explanations about what you have. So usually you have a capital B somewhere with some numbers before. So it's the size of the model in billions of parameters. And usually bigger is better, but it's slower and it also requires more capacity. And you will see many different names on the leaderboard, for instance. Honestly, I think there must be half a dozen of them that enter at some point the leaderboard every week. But if you look closely, there are only a few families. You've got, for instance, currently you've got the Llama models, the Phi models, the Falcon models, the Mistral models. If you look at the big families, the one that starts from a newly trained LLM, you've got less than a dozen of them at most. But then you've got variants, fine-tunings, merging, right? Because now we know how to merge two models. So people do funny experiments where they take this fine-tuning of this model and this fine-tuning of this model and try to merge this together. And they constantly do that. And then you've got specific fine-tuning for the model to obey instruction, specific fine-tuning for the model to be able to perform chat operation. And yeah, so it goes basically all directions. But only, yeah, I say a dozen families most. So for instance, the instrument fine-tuning is something that for my work I use a lot. So I forgot to tell you that, but LLM are generative models, but many people forget what does that mean. That means that you enter a sequence of characters, which is a text, and then the LLM just try to extrapolate what's happened there. And so basically, when you do an instrument fine-tuning, do something where, okay, the text, the inputs, you transform, explicit state, okay, this is the instruction, and this is what you should respond. This is the instruction, this is what you should respond. So you've got an instruct format, and usually, if you look at the card of the model on your interface, it will tell you information about the instruct format. Don't always trust it. Sometimes they make typo, they copy the instruction from other LLMs. That's not a good one. But you've got an instruction, for instance, it can be just instruction, the instruction, output, the output. And you've got fine-tuning for chat, where, okay, you are the user, you are the assistant, you are the user, you are the assistant. The system, that is the context, tells you that this information is available. And you've got things for code, you've got, for instance, for code, when you have a def and name of function and then a docstring, it triggers the fact, okay, now I need to build a function that completes this. So this type of things you've got to do. Last but not least, about formats, GGUF, so formerly known as GGML. I may be wrong, but for me, it's like JPEG, but for large language models. So it's a compression format. And basically, it does some very, very dirty quantization, like, okay, this thing is a float on 16 bits. Yeah, maybe 3 bits are enough. So it's very dirty, but it's smart dirty in the sense that it tries to do this with a block system, like, okay, you make a block of weights and you do some variation in this block. And so it's really like JPEG. It's a multi-scale way of doing weights. It's very fast to perform, like compressing, take a big model and you can compress it yourself on your laptop. It's relatively fast. So I was very surprised. And you've got something much smaller. We're talking here 5 times smaller, 4 to 5 times, much faster, kind of a consequence. And the cons here, you have losses, so it will be more prone to hallucination. It will give you wrong facts or wrong deduction, whereas the original model gave you a good facts and good deduction. So it will be yes, a bit more numb. And as far as I understand, it's kind of frozen. Like, okay, when you build a GGUF version of a language model, you cannot continue to fine-tune and change it. No, you need to start from the full model, do your thingies, and then compress. I may be wrong, but everyone seems to always start from the full model and then perform the compression. Okay, so for today, we'll just show you 2 models, P2. So it's a model from Microsoft. Its main characteristic is it's very small, 2.7 billion parameters. So just so you know the numbers. Currently, the big winners are between 70 to 200 billions of parameters, the one that can have almost GPT-4 performance. I'm talking about the open source LLM. You can have nice things down to 7 billions. And until a few months ago, below 7 billions, it was very difficult to have nice things, except for very, very specific tasks like small translation, things like that. And P2 is one of the first model with less than 7 billion parameters to have a good general way of doing things. So it's not GPT-3, it's more like GPT-2, but it's natively good. And it's got its own prompt format. And then you've got Mistral, which is bigger, it's 7 billion, but it's relatively impressive because it's, yeah, I wrote GPT 3.5, let's say GPT-3, but still impressive for 7 billion models. And for some reason, the instruction is very specific with this start instruction, end of instruction, very specific. You cannot, if you try to do the wrong prompt for the given model, you will have very strange results in the end because it will be lost. So how do you load the model? So I will not execute this, but you've got a nice method from pre-train where you basically just enter the repository name, unique face of the model you want to load. You want to have a specific file name because if you see in each repository, you've got multiple files and you just tell, okay, this is the file I want to get. And I will not execute this, especially because on Windows, the browser fast executes some things relatively strange. Oops, it was on my other laptop, just to see there. I will remove verbose, otherwise I will have some issues, but I can execute. Okay, so this is loaded. I will just, sorry, this is things of Windows. You need to reload it because otherwise we'll have verbose everywhere. So it's loaded inside the Jupyter Notebook. Other version is if you have the server option, you can execute this and it will just run in the background a server, web server that will be able to handle the call to the LLM. And for so here I've got two versions of Fefi, one inside the notebook and one inside another server. Just for people that are used to a REST API and things like that. Okay, Bonaldi effect. Bonaldi effect. Oh yes, I know what happened. Ta-da! Yes. So you've got here a description of what are the endpoints of your API. The client choose that. Yeah, feel free to browse. And you tell me, but it's very complicated. I have one thing if it runs on the server, one thing if it runs on the local notebook. No, in fact not. It's very easy. Oh, just, yes, I forgot. When you load something, you can have multiple parameters. There is a list in the API of Llama CPP. Two of them are very important. The context size basically tells how many tokens are more or less words. You can have in your model, like for instance, if you have, I don't know, 50 tokens, that is, you will have one sentence, two sentences at most. And the bigger the context, well, the bigger the resources, but you could have large inputs and large outputs. And it will always cut if the budget is overridden, so you have to choose your context size carefully. And if you want to enable CUDA, the number of GPU layers tells how many of the layers of the model you can offload to the GPU. So by default, it's 0, everything on CPU, -1, offload everything on the GPU if it can. And if you set a number, you can have part of the things on GPU, part of the things on CPU. So yes, when you want to use a model, first thing is to be adaptive to what your model is expecting from you. Like for instance, okay, if it's an instruct model, you've got to specify the instruction format. Some models can have automatically shipped templates with a card. For now, I prefer to build my templates myself to play with them. For instance, here I remove the space because I noticed that sometimes it expects a tab, not a space, and it hallucinated when I add a space there. So I remove the space, stop hallucinating. Okay, granted. Never try to contradict the LLM because I don't understand what happens. So yes, so this is the prompt format for V2, the prompt format from Mistral. And here I will have some option, the prompt, what you send to the thing, and then you've got some parameters. So max token, it's the max size of the output. So the context will give you the input plus output size, and the max token will give you down the output size. However, that will go there. But the thing is that when you have an option, you can send them to your local copy of the LLM. Here I had the question, I guess it was, yes, name 3 stars. I hope I will not have a energy effect. No, after effect. Okay, it's slow, but usually, oh, sometimes the thing, the answering time depends on the length of the answer, and sometimes it's very short, and sometimes it decides to write a novel. Apparently, yes, it decides to write a novel. Oh, yes. This one is actually relatively interesting, and I will come to that later. Oh, actually, I love this because it will help to do something later. Just remember this. And here I will do exactly the same thing, but instead of passing the options to LLM objects, I pass at JSON in a post request. Be to the point, be to the point. Yes. Okay. And you see, it's the same options, the same type of output. So yeah, whether you decide to host it on the web server or use it locally, you don't have to think it through. And so here the good things there. Actually, here I don't use the web server of Fifi, but I will use a web instance of Mistral hosted on Hyperion because I want it to be fast. And okay, so this will hurt. So I'm asking locally on my C2 to explain the theory of stable matchings. And I know it's verbose when it does that. So I will have something. Avec Suna, yes.
So just taking the opportunity to say that the notebook of the presentation is on the website. It's already on the website. Thanks, Fabien. And also that, generally speaking, we put the videos of the reviews on the website. In particular, there is the video of Gerard's session on
yeah,
which dates back a little. That's 3 years ago, but it's on the website.
Oh, yes. So it took 1 minute. It's running right there. And in 1 minute, you've got, so was it an hallucination or not? V2 tends to, introduced by error. Come on, guys, come on. So the words are there, the context is there, but here V2, yeah, it's an hallucination, you can say that. It's a semi-hallucination.
More reasonable to say arrow than to say Marie.
Yeah. And so let's try using the other one. I just up the yeah. So this is the point where I need to reconnect. Everything is running. It's part in the 2 GB. No. So this is the 7 billion. So V2, the memory space, it's less than 2 GB, and Mistral, it's I believe 5 GB. Right, here we've got the Gall-Chapelle algorithm. So blocking pair. So I don't want to read in details, but in terms of from above, it's parameter to be best. Yeah. So yeah, because it's fast, I can run it multiple times. Actually, this was the thing impressive. The speed, because it's almost the same speed, but GPT-3 had last year, if you think about it. No woman preferred. Yeah. So just about the parameters, like when you load the model, you've got a bunch of parameters. When you run a query, you've got other parameters. And the important thing is a list of stop that are basically int to tell the model to stop outputting what it's currently outputting. And actually, we add a very nice example there, because actually here it was like maybe part of the training was with Q, A, and he's on the run, so he continue. He gives okay, new answer, new question, and sometimes he gives you like a full range of questions and answers. And yeah, the stops are to say, okay, guys, don't go further. You've done your job. It's fun because, as always with LLM, it's very hard to reproduce, except if you specify a seed, but I didn't have the time. So I'm glad he made this mistake, because it's a mistake. What else? So we've got some parameters that kind of fine-tune the imagination, like temperature. I believe it's like, like in physics, the amount of randomness that try to think. And at every time, at every step, you need to branch out between multiple options. And for instance, top K, say branch out, but by choosing from the K most probable choice. And top P, where P is a probability, okay, make enough choice to cover, say, 50% of probabilities among the top choices. And then this is someone you will select above using temperature to do some things to select more or less. So basically, if you select temperature to 0, I think you always take the most probable output. And yeah, you just play with that. You've got a bunch of other parameters. Obviously, I don't know most of them. But so if you want your system to be fully hallucinating, you just take a very large K, a very large temperature, and yo-ho, let's go. And just to conclude, but now you will see that it will be actually very easy to do, how to have a simple interface for LLM using IPyWidget. Thank you. So what you do, in the instruction, you can tell the LLM how it should behave. Like, okay, you're speaking to the child, you are a Democrat voter, you are a Republican voter, you're a pirate, you are always short in your answers. You prepare some context. I will keep, because the context I change the context and prefer the other one. And then you do your function. So here I will just say, and this is for what happens before, if there is no question, just tell something interested. By default, you use the short tone, and you craft your prompt according to that. So here, for instance, if I still have my connection, yes. Wow. Yeah. Oh, I did find the tones. Yeah, it's the LLM. Basically, the main thing and the stronger thing about LLM is it understands, with quotes, natural language. So you just part of the art of prompt engineering is find the phrasing that will have the most resonance with the model. Yeah. For instance, here actually, this is the old one. The new one is you are Jack Sparrow. but you don't say your name, because otherwise he always says, I am Jack Sparrow, blah, blah, blah. So I say, okay, you are Jack Sparrow, but you don't say your name. And it's actually much better than this one to have a pirate tongue. So it's, yeah. And so here you have a bunch of questions. You make, so combo is just, you enter what you want, but you have a pre-selection that you can use if you want. And it's like before, so you just have to put all things together. Ta-da! And here you have. So you see, I don't. Oh yes, yes, I can't. Oh yes, yes, I didn't fine tune properly, and that answer. Yeah, and you can play with that. So you will be able to play with that and try to. Yeah, it's really fun. Okay, so just to conclude, I hope I have convinced you that if you want to play with LLM, it's very easy to have a very simple interface in no time. The overhead to take LLM and deploy it on a notebook is almost zero. My personal conviction is that it's very, 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 very fast in the evolution. Like, for instance, every 6 months, I kind of dive into the interface, try to extract the best models. And 6 months ago, I couldn't go below, I believe, 13 billion parameters to have decent results. And it was very slow. And I was surprised, okay, this one works well, fit to end of work. So I'm convinced that in 6 months, all these models will be outdated and we will have a much performance model of the same size or of a smaller size. And that's good. And just for people who want to really build a ChatGPT-like interface, there are tools that kind of mimic the user interface. I saw them at some point. I didn't register them. I didn't try them because it's not my job to build, to mimic fully the GPT interface. But if you want to have a real experience, actually you can. And you can have your own chat GPT running on your computer if you want. Of course, GPU X. And I think that's it. Thank you again for your attention. We've got people from the chat. Thanks a lot.
Questions? Yes. One model, c'est déjà un peu product moyen pour dire autre chose, donc on va.
So here I showed you the way with GGUF files. So it works with most GGUF files. But 1 year ago, it was GGML files. And that changed the format in August, I believe. So, but the good news is people understand that it's nice to have a compressed version. And for the good ones, the good models, you have some people like the block, for instance, that always takes the version of the good models and puts them in GGUF. And it's all related to Llama CPP, which is an initiative to be able to have fast access to run decoder-only models. So yeah, it should stick for at least 1 year, I believe. And even if the format change, you will just have to change, update your Llama CPP version, and there you go. The only thing that could prevent that is if people decide to change dominant neural architecture that is used. Currently, everyone uses decoder-only transformers, almost everyone, and this is the architecture that GGUF works for. But for instance, I wanted to use a translation tool from Facebook, and I couldn't because it was a decoder-encoder approach, and so there was no GGUF version easily available for that model. I still haven't. You mean like a stable diffusion or things like that? Honestly, I never tried to see how they fit together. The part where you change the nature of the input or output, like text or whatever, it's something I didn't play with yet, so I can't.
Other questions?
Yes, can you hear me?
Yeah.
I wanted to ask, in the case of the Mistral that you show, you are running it with GPU or?
Yeah.
Okay.
Yeah. It's actually okay. It's there. I don't know because I get the deconnection. Yeah. So it's running. So this is the Mistral running on Hyperion, and actually you see it's 3 gigabytes per Hyperion card. So basically, if you've got 8 gigabytes of video RAM, you can run the Mistral locally. Yeah.
Mm-hmm. Perfect. Thank you.
Yes, and I insist that there is no information from the internet apart the only information we give is in the prompt here.
Yes.
Probably. But I'm still very reluctant for code generating. Yes, for simple things, yes, it will work. Maybe we can try.
The pirates.
Peut-être un IPyWidget.
That's needed.
Not enough. Maybe so I don't remember the context size. Where did I took the context? Oh, the call Mistral. Where is the call Mistral? But yes, sorry, but maybe I will just regenerate. Sometimes it works. IPyWidget, you meet quoi? Qu'est-ce que tu veux dire?
Code snippets.
Bon, alors, relatively, I don't know what's underneath, but yeah. No obvious mistake. And yes, private dash. The magical finger magic. We all be interactive. So yes, but maybe I'm wrong, but I'm still, like I said, reluctant for complex coding things. But yes, it can avoid you to go look for Stack Overflow. But on the other hand, when you know that Stack Overflow were used to fuel the LLM, I'm afraid that if people start to always use LLM to answer solutions, it will kind of destroy the source of the intelligence of the solution you have. So yeah, try to go to Stack Overflow's team to ask a question, please.